Hello, good evening to everyone. This is Professor K. R. Chari. Earlier, I was with the Birla Institute of Management Technology for a good long 20 years as a professor of operations management and also the Dean Student Affairs. Now, before joining the academics, I spent about close to 4 decades after my engineering in with the industries, a wide range of industries, and there was a lot of learning for me. And over a period of time, through these learnings and working with the industries, I started getting more curious about the actual shop floor problem solving, productivity improvement, operations efficiency, and every efficiency of all the resources that we talk about. Because productivity is all to do with efficient utilization of resources, that is the men, the material, the machine, and energy and the capital. Okay, these are basic resources that go into any system, any production system or operation system. Now, over a period of time, I've been observing that in the industries there is always a lot of scope uh, for improvement of the efficiencies of conversion of the resources into finished product. And all that matters is how keenly we look at what is happening today and what actually perhaps should be happening, or an improvement. It's a continuous improvement process. uh, in my view, there is nothing called best in the world, because I firmly believe that even the best can be bettered. So we don't know where we stand today, but we always want to keep bettering the operations and our performances. Now, with this in mind, uh, I thought, I've been meeting my colleagues and, discussing about the cases, both teaching cases, learning cases, research papers, and everything. So I thought this is an effort to bring to you all a real-time industry scenario where you can think about the application of all the basic operation research approaches, methodologies, tools, but very particularly about the questioning technique. Basically, what we talk about is that unless I question something, you don't come up with a better option all the time. And I think the basic question are like, what are we doing? Why we are doing that? And who is doing it? And how are we doing it? Is that the best possible way to do it? So there's a methodology for that, which I will subsequently deal with that. But through let me take you through one of the live experiences, like a live cases, and see how these things can be applied in real life. The blocked mind that we have, the way we have stopped thinking about things, and how we can creatively think about improvements. Okay, with that in mind, now, let me just take you around one of the processes of mass manufacturing of, rotis in a centralized kitchen, which caters to more than a lakh of, school children every day. And, we are talking about like making about 5 lakh rotis per shift for the, midday meals kind, and how the process goes, and then we will get to know what the places where we can uh, apply this questioning technique and see the results coming out. Okay, with that, friends, I will stop here and let us start with the process. Let's now look at the process of making these rotis. Okay, the raw dough from the bags, storage bags, it is transferred to these mixing machines. They are also called kneading machines. Okay, the dough kneading. And in that process, what really happens is, the dough gets properly blended with water. Uh, there are estimated quantities and ratios of the dough to, I mean, the flour to water, and they are mixed up with this one. And, then the kneading takes place. First mixing, then kneading. And this kneaded dough is transferred to this rolling machine. The purpose of this rolling machine is to get a uniform thickness sheet out of which the rotis can be stamped out. And once they are done with this, this is a trouble point because the starting time from the starting to the time when the uniform sheet of the dough comes out, you know, a lot of runs and reruns have to be taken up, and it takes close to about 20 minutes time from the start to start getting a uniformly distributed flat sheet of dough from which the rotis can be stamped out. And till that time, all this extra material, uneven material is transferred to the one. And once the uniform sheet starts coming, you know, the rotis are stamped there, and this extra stamped out material goes back to again the rolling machine. And what we have here is the round, beautiful rotis coming out. That is what we want. And they go through this the hot plate, actually equivalent of tawa in that. And there are times because of starting non-uniformity, there are times when the hot plates are running idle. There are no rotis on that, and slowly after some time, once it stabilizes, the rotis start uniformly coming up, and you start getting them ready for eating. This is how the whole process goes out after stamping from the flat sheet. Okay, and these are the rotis coming out. And once they go out, these are in the dry format, and you need to spray some oil, apply some oil on the surface of this, and there is a small machine here. Next to that, it will take us where the a very thin micronic thickness film of oil is sprayed on this. And now the rotis are ready for getting packed. And here is a large fleet of the operators who are engaged in counting the rotis depending on the schools and where to which school the rotis have to go, how many have to go. And they pack them in containers, roti containers. That's a whole stock of rotis to cater to, 120,000 meals, uh, midday meals per day for the schools which are distanced as far as up to 90 kilometers from the this kitchen. So that's how it is, stacked, and now it is all ready. Now from here on, if we continue further and see in the reverse cycle, this is how the rotis are coming, and you can see all over the oil sprayed and spilled over there. Further up is fresh dry rotis coming, and this is where they are stamped, and we are going in the reverse cycle now to understand the process. Okay, and the stamped out part, the cut out part of the dough goes back for the rolling machine where it gets converted into another flat sheet. Okay, and there is about three of the operators are engaged here for just putting it back onto the conveyor in case it gets stuck. It can get stuck any point of time. Now, this is how the whole process goes, and well, this is how the rotis are covered. Now, at this point, you ask a few questions to the student. What did you see? What did you like the most? Any critical observations? Any suggestions that you have in mind? And well, one student start thinking, lots of those observations come because everybody is observant. Some of the observations are like, very interesting, sir. Automation is very good for mass manufacturing. Hygiene factor, workers are not wearing gloves. Initial starting time is high till the dough sheet gets stabilized uniformly. Conveyor from the kneading machine to rolling machine must be installed to reduce manpower. Finished rotis stacking and packing can be mechanized. So coming to the hygiene factor first, what these normally the students observe is the way the workers are handling the dough in the mixing and kneading machines, okay, and transferring them onto the rolling machine. There's a lot of manual handling, and this is perhaps comes to the notice of the students, that hygiene is a factor, and they could have perhaps used gloves. The while waiting for the uniform dough sheet, this again they are handling like this. So this comes to the notice of students. And then we come here to the next. Initial starting time is high till the dough sheet stabilizes and becomes uniformly spread. Yes, that's a beautiful observation. You know, you see the empty rolls running, empty machine running. There's a lot of power and a lot of electricity that is consumed. And all this material that is not uniform again goes back for the same process again and again and again till the entire thing is uniformly blended and converted into a rolled sheet. Okay, so you know that again and again rehandling, lot of rehandling is there in the initial phases, about 20 minutes from the starting time roughly. Okay, and once this roll has come up, you know, this is how a lot of reprocessing takes place here. And now the roll has come, and now the rotis are almost ready to be stamped out from the uniform sheet that has been formed now. The see this whole process now that is where it has stabilized, and now we get the stamped out rotis, round rotis, and how it is transferred onto the hot plates, and the roti gets baked, and it goes into three cycles actually, up and down, so that the lowest temperature goes to the highest. Next, coming to the conveyor from kneading machine to rolling machine must be installed to reduce movement of workers. They also feel that this will reduce the impact of the hygiene factor too once the conveyor is there. So let us have a quick look at this. Now, this is transfer. No? This can be mechanized, perhaps, and very good observation made normally by the students. And well, let us go. This again a lot of repetition here, the thing, but just to understand, what are those observations they made, and how they have come to that conclusion. And once this whole process is there, the next item comes about is the waste flame reducing productivity of gas, excess consumption, and higher cost of operation. Now, we must have seen, that till the time the uniform sheet of the dough starts coming, this is going to happen. So, how to synchronize the whole process, that whether to delay the process of heating the plates till the dough gets uniform and then start the flame, or, lot many questions keep coming to the mind of people. But productivity is a factor. Coming spraying oil spillage is high. That's also a very good observation, because the roti is not uniform, but the spraying machine uniformly keeps spraying the oil. Of course, the oil is recycled, but uh, still the observation is right. Now coming to, but none makes any comment on the observation that we are going to see generally. This is where we see the dough coming out from the roti stamping process, where the round rotis are stamped out and the rest of the sheet of the dough is transferred back to the process. They have taken it for granted that this is a normal procedure. But from the operational efficiency part of it, if you see, what we are actually saying is we are cutting out a circular roti from almost a rectangular block or rectangular sheet. And, that is where all the geometry goes about. And if we quickly see, what are your comments on this part if you ask? This is road survey. That's all beautiful, and by stamping round roti, we are forced to reprocess a large portion of the dough, which is resulting in waste of processing caused by way of electricity consumption in motor. Because that now let us see how much part of this. Our roti size is 6 inches diameter, and we take a 6.5 inch square dough sheet with half-inch margin between two rotis for stamping. Okay, on an average, this is how it is stamped, and this is how. Then the blue is this dough sheet, and the orange is this stamped roti. Now, my 6 inches diameter requirement is equivalent of about 5.32 inch square. Why can't we make square or rectangular rotis which can save reprocessing and thereby help in reducing the cost of operation? And here comes the routine and traditional response. How can you make a square or rectangular roti? Because the rotis has to be round A rectangular or square will not be fluffy. The rulers have only round stamping dies. Students will not like square or rectangular. All kinds of objections are raised. And what is a look at the productivity? If you say from a 6.5 inch square, you are cutting out a 6 inches round circle, which is only 28.28 square inches, and the overall productivity is only 67%. That is, rest 0.33 or 33% is going for reprocessing. And if you see 0.33 over 67 is almost 50% more than what you really need. So he said, after all these observations of believing, seeing is believing, so we tried. He said, why can't you make square rotis? Why the objection at all? And now if you have a look at this, the same stamping from round rotis, it was converted into 7 uh, sample pieces just to see whether their objections and their resistances were right or not, whether the roti comes fluffy or not, or whether there is any problem. So this is what was done in this case. And then when the roadies came out, they were manually loaded because naturally it was a sample study. And all that is needed is tomorrow, if it works, the round circular stamping roller die, you have to just change the straight sheets, I mean straight blades. So you get either a square or a rectangular roti. But their doubt was whether rectangular rotis will be fluffy or not. So it's a seeing is believing. Just try it out and see. And you see what comes out here. Wow, there it is, as good as the normal other rotis. So all your doubts about fluffiness and floating and bloating and all, they are ruled out now. That means a square or rectangular roti will work, and that will save us almost like 50% of the material being reprocessed, and thereby overall 33% of cost of operation can be saved. Okay. Now, this exactly is what we are trying to teach the students in this whole course, like the critical analysis, critical observation, and questioning habit. That's it. Good. Every organization needs and wants to grow, and growth is what is inherent for any entity to survive in the first place and steadily expand. The growth can be achieved only if we have the reallocable surpluses which can be pulled back into the capital of the organization. And these reallocable surpluses, they come out of the net profits made by the organization. And net profits are nothing but the total gross revenue minus gross expenditure. And here we must remember that gross expenditure means all assignable costs incurred by the organization, including the taxes and all payables. Now, once you reduce this, the gross revenue minus gross expenditure becomes my net profit, which is available for me to reallocate to the capital, which will ensure growth. And at this stage, we want that the gross revenues should be maximized to the extent possible, and the gross expenditure to be minimized to the extent possible, so that my net profit are maximized. Thus, the reallocable surpluses are maximized, and the growth also can be maximized.